Hi students, in this video we are going to discussing about the multiplexer. The particular multiplexer is simply said as MUX. We are going to mention the first three letters of the multiplexer MUX, MUX. In this particular multiplexer, we are having the 2 to the power of n number of input lines, and also we are having the one output, so that the particular output corresponds to the input based upon the n number of control signals. Based upon the control signal, any one of the input will be connected with the output, or otherwise we are going to set that the output will be chosen any one of the data input signal based upon the control signals. So that's why it is named as a data selector. So it can select any one of the data from the input lines. The output will be corresponds to the any one of the input, and also it will be based upon the number of the based upon the n number of control signals. So in this particular case we are having the 2 to the power of n input line, means we must have the n control signals or control lines, and also we must have only single output. So this will be clearly mentioned in the block diagram of the multiplexer. In this multiplexer, it's having the 2 to the power of n data input lines, and also it's having single output. So it may be referred as 2 to the power of n is to 1 combinational circuit, or otherwise they can simply ask about implement the combinational circuit with 2 to the power of n is to 1 line, n is to 1, 2 to the power of n is to 1 control lines. They are asking about like that also. So it may be we are having the 2 to the power of n number of data input line, means we must have the n will be n number of control signals in this particular multiplexer. So in this multiplexer we have to consider the three major components. One is the input line, another one is output, and also we must concentrate on the control signals. As we compared with the encoders and decoders, there is no control signals is available, but in the multiplexer we are having the control signals. Based upon the control signals only, the data input lines will be based upon the control signals only, the input lines will be reflected in the output side. So this is known as the multiplexer in this particular multiplexer. Now we can see the 2 to 1 line multiplexer. In this particular thing we are having the two input lines, and also we are having one output lines. As per our concept in our multiplexer, we are having the 2 to the power of n number of input, means we must have the n number of control signals. Here we are having the two input signals, so the value 2 to the power of n will be written as 2 to the power of 1. So we must have the one control signal. So the particular control line or control signal, it will be referred in the letter S in the diagram. And also we are having the two inputs, input 0 I0 and I1 input 1, and also these things will be connected as per the diagram. So you can see the diagram. The first thing, the input and the inputs are connected with the one of the input of the AND gate, and the remaining one of the input will be connected with the control signals, if it is as per our concept. So in our 2 to 1 line multiplexer, we must have we are having two input lines, and also we are having one output line. If it is the control signal, see it's having the single control signal. So in this particular control signal, the control signal, it may be a 0 or it may be a 1. If it is 0, the control signal value is 0, or otherwise s equal to 0, means the I naught will be connected to the output. If it is the I1 will be connected to the output, at that time the S1 will be 1. So as per our diagram, we are going to connect the S value with the I1 input 1 and also S0 value with the I0 through the AND gate, and the output of the AND gate will be connected together in the OR gate. The output of the OR gate will be the final output line of the 2 to 1 line multiplexer. So in this case, you can see this, we are going to make it as a S equal to 0. At that time, if as per our AND gate condition, both the inputs are high, means at that time only the output will be reflected to that. So if it is, you move the input. So now we are going to whatever the things. So the S will be equal to 0, means I0 will be reflected to the output. How it is? So you can see this. So S equal to 0, so S bar equal to 1. So the input of the input of the first AND gate will be 1, and also I0, whatever may be the I0 may be 1 or 0, it may be reflected in the output of the particular AND gate. So that the particular value will be reflected to the Y. If it is at that same time the S equal to 0, means the 0 will be given to the second AND gate. At that moment I1 will be whatever the I1, so the output is 0. So the output 0, it cannot create any impact on the Y. So the same thing will be happens for the S equal to 1. So S equal to 1 means at that moment the I1 and I1 input will be reflected to the output side. The I0 will be suppressed on the gate itself. So you can see the truth table for the 2:1 multiplexer. So it is known as, if the S equal to 0, the output will be corresponds to the input 0 signal, I0 signal. The S equal to 1, the output will be corresponds to the input signal 1, right? This is known as a 2:1 multiplex. Now we can see the 4:1 multiplexer. In this particular 4:1, 4 will be the input line, means we are going to write it as 2 to the power of n. 2 to the power of 2 will be equal to 4 input lines. 4. So the 4 input lines will be arrived from the formula 2 to the power of 2. So that we must need a 2 signals, control signals. So if we are going to connect the two control signals, as it is S0 and S1. So in this particular case, each input will be connected with the both the control signals. So we are going to adopt the 3 input AND gate. So the I0 will be connected with the S0 and the S1 controls from the control signals. So in this particular case, I0 will be connected with the S0 bar and S1 bar, and I1 will be connected with the S0. I1 will be connected with the S0 bar and S0 and S1 bar. I2 will be connected with the S1 bar and S0. I3 will be connected with the S1 and S0. So it will be reflect the sequence of the 0 0 0 1 1 0 and 1 1. So if it is, we are going to give the value for the S0 and S1, both are equal to 0, means at that time the I0 will be connected with the output. If it is, we are going to apply the control signal as 1 0, means I2 will be connected with that. So the finally we are going to give the control signals both are 1, means at that time the I3 will be connected with the output lines. So it is the logic diagram for our 4 to 1 line multiplexer. So you can see the truth table for the 4:1 multiplexer based upon the control signals. If it is the both the signals are 0, means the I0 is connected to the output. 0 1 means the I1 is connected to the output. 1 0 means the I2 is connected. 1 1 means I3 will be connected with the particular multiplexer.